From a broad field of strong nominations from all over the world, the selection committee is awarding this year's Brain Prize to 3 scientists for their foundational work in theoretical and computational neuroscience. The Brain Prize 2024 goes to Professor Terry Sanowski, Professor Larry Abbott, and Professor Haim Sompolinsky.
We are living in an era of remarkable transformation, led by a powerful technology. A technology capable of mimicking the workings of the human brain that is reshaping our world in ways we couldn't have imagined even a decade ago. It writes, it sees, it even diagnoses diseases. Many paths led to this world-changing technological revolution. One of them is the remarkable story of how research into the human brain paved the way for what we now know as artificial intelligence.
The group of us were drawn by the mystery of the brain and the importance of making progress. Every thought that passes through our mind, every decision that we make, every movement that we make involves the concerted effort of large populations of neurons. So it is impossible to understand how this emerges without the tools and the concept of physics.
Physicists had a long tradition of developing theories and models of things that are hard to measure or experiment on directly. The most groundbreaking models of the brain were artificial neural networks. With these, scientists could start figuring out how billions of neurons in the brain work together. These artificial neural networks could mimic functions of the human brain, like how we generate speech.
Haim Sompolinsky also has a background in physics, and he's built models of the collective behavior of large numbers of neurons to try to understand their dynamic activity and how they actually go about solving a whole range of problems in perception and memory and in action as well.
The brain is enormous in the complexity of its microscopic structure. The more we learn about the brain, the more we are at awe about that complexity. I see AI as a major revolution, not only in technology, but also in potentially new ways to understand the brain.
I think it's absolutely fantastic that physicists are taking an interest in the brain, because they're bringing models with a degree of quantitative precision that we've not seen before. And Haim has been at the center of that development within our subject.
My father, he worked as a scientist. His bookshelf was completely chaotic mix of books on the Jewish law, on the Torah, a book on the integral and differential mathematics, or some encyclopedia. That was the kind of spirit at our home, and this is the legacy that he left for me. When I finished my PhD in physics, I went to Harvard. I was looking for problems which are poorly understood, where I can really make an impact. I decided to focus on spin glasses. So my studies of these structures revealed the world of physics of disordered systems. And that really initiated my entry into neural networks and the mystery of the brain. The first stage of that career change left us more or less isolated. Physicists saw what we did as not physics but biology. And biologists were wondering what physicists have to do in neuroscience. When we started transitioning to neuroscience, we formed a coalition of researchers from the medical school, from the life science, mathematicians. The terminology was different, and we spent considerable effort to, first of all, establish a common language. The interactions between AI and neuroscience is going to be very fruitful and productive from both sides. I hope that what we will see in the future is AI for the brain diseases. The Brain Prize is a recognition of the field, recognition of the important role of theory and computation in understanding the brain.